Okay, so let us start. I hope you had a good break. Oh God. Okay. So, what is left with us? Sorry, you don't remember? Arena, yes, Arena plus projects. You forgot about project, or you remember about your project? So we'll be doing both together. Okay. Let us start with where we left. You all have collected the data. I think I have to apologize. One group they sent me something, but last week I was away traveling, so I couldn't respond. But let's hope that you have collected the data well. Okay. Now the data should look something like this for all of you, isn't it? So can you explain me the arrival process in all your cases? Arrival means like, from the technical terms, what distribution you expect this to follow, the arrival rates. You have remember anything about the nature of process, something called Markovian arrival? What is Markovian arrival? You are, I think, still coming out of break. So let me explain. Okay. There's something called independent arrival. You remember that? So independent arrival follows a particular kind of a distribution. There is a name for it. You remember the name? Let me give you a few choices. Normal distribution, triangular distribution, Poisson distribution, and exponential distribution. So what is that? Okay. Why not exponential? Exponential amount of time. That's good to hear. The rate, for the rates, we use Poisson because it's discrete. Okay. Everyone with me? But for the times, we use exponential is nothing but the same sister distribution for continuous data. Because time is continuous, so we'll be using exponential. Okay. Now let's just go to this case. There are two ways we'll be handling, fitting the distribution in two senses. So whether you talk about Poisson or whether you talk about exponential, there are only one parameter in both distributions. Anybody remember the name of those parameters? Queuing chapter. You have to quickly in your mind refresh the queuing chapter. Let me give you a hint. Some Latin letter. Yeah, the mu and the lambdas, right? So lambda is for exponential, and you can use mu as well in both. By the way, lambda and mu are just the same thing. Okay. So mean arrival rate is what you need. Okay. So how can I find the mean arrival rate? So let's look at this table. Isn't this what you have done? You have time here. For each minute, you counted how many customers. Everybody agree that you were doing that, right? So there's no confusion here. So we needed to find, this is the lambda for it. Lambda is nothing but mean arrival rate. So how can we find mean arrival rate? This is arrival in first minute, second minute, third minute, fourth minute. What is the unit for mean arrival rate? Customers per minute, right? Now you want not only customer per minute but mean. So how can you find that from this data? By the average. That's it. So you go down there, and you see the formula here. I'm just taking average. Not very difficult, right? So all you have to do is to take average. Now, Even after exam, even after project, don't forget what I'm discussing here. These things there will be questions from what you have learned during project in the final exam. Okay. So whatever we are discussing from here till the end, everything, something can come from, in exam relevant to that. Do you all register that? Don't forget. From here onward, there can be significant questions in MCQs to actual problems. Okay, so we have done that. Now, what is mu? Can somebody explain me? This is customers per minute arrival. But what is mu? Still a rate. Mu is still a rate. Okay. So mu is not customer arriving per minute. Mean customer number of customer arriving per customer served per minute. Just a different shape, but it's still a rate. Remember this this is where everyone, a lot of people make mistake. Mu is still, we're talking about rates. You all register that? Now, because there is a small subtle difference. Now, if I want to convert this into times, because here I'm not recording customer served per minute. We are not doing that. So how can I find mu? How can I find mu? This will give me what? Mu? And then? No, there was a discussion. Let me help you recall that. If I want minutes per customer in the unit, what should I do? I want, in numerator we have customer, in denominator we have time. And this is like lambda. I want minutes to go up, minutes per customer, isn't it? What is service time? I want this minutes to be up. So what can I do? That's it. So if I have recorded time, so this is mean time. This is mean time. Whether I talk about lambda, or I can say mu, or I can say 1 over mu. You all understand this very well. So if this will give me mean service time. This is mean service time, not mu. 1 over mu. This whole thing 1 over mu is what? Mean service time. So you know the relationship between mean service time and service rate. Mu is the service rate, but 1 over mu is the mean service time. Remember this relationship very well. Okay. Now, what have we recorded here? So if I take average, what am I determining? Give me exactly 1 over what? 1 over mu. Because I'll go back to what I just said here. You have to register this in your head very well. Mu is the service rate, customers served per minute. 1 over mu, this whole term 1 over mu is average service time. Can somebody explain me again what I just said? What is mu? Which is, what is the unit for that? Customer per minute. Always remember two things. There's a mirror. Both, there are two completely related things. One is the rate, the other is the time. Rate, always rate, it will be customers per some unit time, customers per minute. Let's just say for simplicity, customers per minute, right? Customers served in each minute. There is a complete relationship between average time spent on a customer in these two quantities. All you do is just 1 over that, and you get the other one. Okay? So if you have time spent on a customer, you're now dealing with time, not rates. So when you deal with rates, think of mu and lambda. But when you think of times, you're dealing with not mu and lambda, but 1 over lambda and 1 over mu. Is that understandable to everyone? Okay, so when you're dealing with rates, the word rates are there. So you are dealing with lambda and mu only. So you always say, okay, rate is given, so I'm looking at lambda and I'm looking at mu. So when the key word here is rates, and rates are always like in customers per minute or hour or whatever, right? Now when I'm dealing with times, not rates, times. So we'll always have minutes per customer. And here I'm not looking at lambda and mu, I'm looking at 1 over lambda and 1 over mu. 1 over lambda and 1 over mu. You understand that? So this whole thing together, we'll say this whole thing is mean service time. What is the word I used there? Did I use rate or time? So when I say mean service time, always, you should always know that you're looking at 1 over that. Okay. So when in the question, whenever it says something about times, go for 1 over. When it says something about rates, go for lambda and mu's. Okay, is that clear now? Now here, what are we dealing with? Is it rates or is it times? Customer per unit time, customer per minute, it's rate. So what we calculated here is lambda, because in rates we are dealing with lambdas and mu's, right? That's why we knew that what we calculated, because it's the rate, what we calculated is actually the lambda. It's customers, average customers served per minute. Now, when we talk about minutes, the service minutes per customer, what are you dealing with? Now you're dealing with time, service time. So if you take average of that, what are you calculating? Because it's service, so service is mu and arrivals are lambda. They are the same thing, right? So when you take the average, what exactly are you calculating? Mu or 1 over mu? That's the only thing you have to remember very well. So once we take the average, we actually calculating 1 over mu, not mu. So because you're calculating 1 over mu, can I get mu from there? All I have to do is to do. What do I have to do? We just have to divide 1 divided with 1.5. You just do 1 over that, right? Look at the formula here. All am I doing is this 1 over this number. But now, whenever you have to reverse, you just do 1 over. Wherever. Okay, so whenever you have to find the numerator to denominator, denominator to numerator, the number, you just do 1 over that. Okay. So how can I find mu? By doing what? 1 over what number? That's it. Is that clear? So you know that both are exponential distributions. Exponential distribution with lambda was 5.07. This is arrival. And this is exponential distribution with mu, how much? If I'm looking at the rates. Now, just to make sure you understand what I have written here, I'm going to write something here that will make you map, what. You remember anything like this? It says normal distribution with parameters mu and sigma. So just like this, exponential distribution is written like this, exponential with lambda, or you can use mu. It's just a way of writing. It says normal distribution. To define normal distribution, you need mu and sigma. For exponential to define, you need lambda or mu. Don't get this confused between lambda and mu. They are the same. Okay. Now, if we are done with it, so both your services and arrivals are following independent scenario, right? Right? You all agree to that? So it means that they are both, the rates will be Poisson and the times will be exponential, right? So all you have to do is to take average and you have the distribution with you. But in Arena, we still need to know some few more things. Where is that? Where is that? Okay. So there is a document given to you. You can look at it, and this is called finding distribution for for the collected data. Okay. So for the arrivals, you can always take average and so on. So you already understand that. But and then you do you see that random exponential value? This is lambda. Somewhere you'll see inshallah in Arena, we'll be entering that. Okay. But I'm going to be telling. I need to tell you something more. If you are not sure about that, and you want to let Arena choose the distribution for you, we have just picked the distribution by ourselves by doing some calculations. Okay, you all understand that what I'm saying here? You right now you have done it manually. You have processed the data, you've taken the averages, and you by understanding the process, you say it's exponential distribution with these parameters, right? Now we are saying that I'm not sure. I have the data, but I'm not sure about it. I want to let Arena pick it for me. So in this case, what do you do? So in this case, what you do is here are the steps, and you can follow this step. Do you have your laptops with you? So all you have to do is to open Notepad. Okay, open Notepad, and then what you have to do is to copy the data that you have saved, put it in the Notepad. Okay. One thing you must remember this. If it's an arrival data, make sure there is no like 0.0 like something like this written here, because the Arena will then assume it to be a continuous number. Make sure there is no like 0.0, 0.0, 0.0 at the end. Yeah, everybody understand this small point? Because Arena will assume that you're trying to fit a continuous distribution and it gets confused. Okay. Make sure that for the arrival data, you use it like this. So I'm going to save it. I'll allow you to open your computers. Your computers are running now. You can use your own data from your projects. You can use your own data, right? So have you opened the Notepad file? Have you copied the data? Your arenas are installed. So can I move to the next step? Vedanth, you want me to wait? Yes. Okay, sure. Let me know when you're ready. Let me know when you're ready, okay? Notepad file. So have you copied the data into the Notepad file? Yeah, I'm waiting, don't worry. Vedanth, I have to reiterate here that whatever we are discussing, you have to very carefully listen to everything, because several exam components are being discussed here, okay? Not just project. Okay, so if you have copied it already, I don't know how you do it in Mac, but in Windows, I hope you're able to see what's going on here. But make sure you set it to all files. Okay, give it a name. Let's say, let me call this arrivals dot dst. Dst is better. If you want, you can give it like CSV, but dst is better. Okay. Yeah, the name of the file, make sure it's not on .txt, make sure you set it to all files, and then better to give it like .dst or CSV is even will work even. So I'm going to save it on desktop for myself. Now this data is saved. Okay. So if you're done saving the data, please let me know. Can I move on? Okay. Now please turn on your arenas. Okay. Now arena is there are some additional tools. But now there are some additional tools software that comes with arena. Okay, so arena is not standalone. So you have to go to arena and then you have to go to tools. Do you see anything on related to input there? Yes, input analyzer. So you just click on input analyzer. Let me see if I can zoom this in a little. The maximum. Okay. Anyways, just go to input analyzer. Just open a new file. Okay. File, data files, use existing. Are you all following me? First open a new file, then go to data files, use existing. Click on use existing. And then you can see that I've saved arrivals.dst. All you have to do is to open it. Are you all here? Have you all reached this point? Sure, I'm going to close it. I'm going to open a new file. Okay. Then I'm going to go to file, data file, and I'm going to do use existing. It means I'm going to be using existing data set. The other option is I'll generate my own. So I'll say use existing, and then I'm going to click on arrivals.dst, the file that I just saved. Then I'll say okay. You'll see a histogram there, right? And some numbers down there. You're okay, Banat? You're following? There are now a couple of options here. One is called fit, and then there's something called fit all. Let's try fit all, the simplest one. Do you see the fit all icon here? Or from fit down there, or you can pick your own. You can say, I want to fit Poisson. You can do that. It will fit Poisson for you. But let me just say fit. Let me just say fit. Fit all summary. Manas, are you all with me? There's a fit all button here. There is a fit all button here. Okay. Click on fit all. And after that, click on fit all summary. Even down there, it is suggesting the best one for me. Down there. So what distribution are you looking at for your cases? Down there, in the summary here, it's giving you the best fit. Sorry? Arena is choosing for you. It's helping you, but you know there is a catch to it. I'll come to that. But I'm asking you, what distribution are you looking at here? What Arena is suggesting to you? Is there anything that Arena is suggesting? Let me use magnifier here because even I can't read. Can you see down here, Bana? Once you say fit all, it is giving you something here down. So can you tell me what is Arena is telling you here? Like for me, it is telling me the uniform with something expression with something squared error. So it must be telling you something here. What is it saying? Beta? I heard beta somewhere. What is the word first line? What is it written there? No, even before that, something is written at the top. Beta. And then there's an expression given to you. So you just have to save the whole expression like this. I'll have to copy. I'm going to copy, even if there are some numbers, I'm going to copy it like this. Copy. And I'm going to save it somewhere. Right? It's beta, it's fine. You know why it's coming beta? There is a reason. I'm going to explain it in a second. But let me just go up to the top. And there's an option called fit all summary. It says for my case that uniform is the best fit. The second best fit is beta, Bible, Erlang, Gamma, and so on. And based on this number called squared error, you don't have to go in there, but you know, it has the least error. You can see that it has the highest error. These are the choices that Arena has thrown at me and saying that uniform is the best fit. Now, Banat, you were expecting Poisson or exponential, something like that, right? So why is it coming beta? That's the answer. I'm really happy to hear that. Yeah, because that's why I told you that once you asked me how much data to collect, I told you that you have to collect as much as you can, infinite number of data points, right? Now, because you have collected it for an hour or 2 hours, I guess, right? So the data you collect is not like truly representative. But we did it for practice. So I just wanted to show you this, that we know that it has to be exponential arrival and exponential service times, but Arena is suggesting to you something else because data is telling you that it is beta or some other thing. You got beta, but what about others? There must be other groups working on that. From back this side, anyone use their you got beta, right? Or beta, you got beta. They got beta. Okay, so what did you get? Okay. So Arena is not working? Oh, okay. So you should tell me this first. Arena doesn't work on Mac. It works on Windows emulators. Even on Windows, it's not working. So what's the error it is giving? Oh, so you haven't installed Arena yet. So you just run the installer first, and it's installed, but when now you're running, it is giving you error. You just have to try reinstalling it, because we have a project to do. Otherwise, can you try it on another computer maybe, or yours is the only one which has Windows? You got? Oh, you so so you got what you were expecting. That's great. Your graph must be like this, high in the beginning, and yes, that's why it was coming out to by so. Can I have a look at the laptop? Can I have a quick look at it? Did I give you an installation copy? I have. It doesn't require folder. It runs like regular program, like in the menu you have Arena, and then you can run. Oh, oh, sorry. It has a password. It's okay. You can show it to me from the other side. Just show me from behind the screen. Oh, that's right. Oh, this is installer package, right? Yeah, Arena is not installed. I think Arena is not installed yet. Yeah, I'm trying to install it now. Do you have a USB drive with you? Let me see if I have one. I can give you one installer. I think I may have it here as well. I don't think I have USB. Anybody has a USB drive? I don't think I have my USB with me. So, oh, okay, I found my USB. Let me pause recording, otherwise it will be just too long. Yes, I selected arrival data. So just like this, you will select the arrival data, you can select. Sorry? So you get an expression, right? Some number plus beta plus something, right? Okay, what I selected was, I had, by the way, it's just a random data, okay? So I selected customer arrival data, and just like this, I'm going to be selecting the time data as well, and I'm going to be saving it again. So I'm doing it twice, okay? First time we just did arrival, okay? Now I'm going to do it for save as, and I'm going to call it service, okay? Let me just do it service. I'm going to save it. I'm going to go to input analyzer again, file, data, use existing, and this time I'm going to be picking where is my service, service. Yes. Sorry. You can use CSV is fine as well. But DST is its native extension, so that is helpful. Okay, so you can see that it's saying now, again, it's saying uniform. It's asking that uniform is like the best fit. Uniform bit, it depends on the data itself. So what I need to save it. I'm going to copy it. I'm going to open another notepad file, and I'm just going to say arrival distribution, and I'm going to save it here. Like this is arrival, and then I'm going to say service distribution, and then I'm going to save the other one. Right? You understand that? We'll be needing this later. I've just copied the same one. Now, just save it, and now we need to go back to Arena to learn a little bit about Arena, okay? Now, I have given you a full-fledged extended 150-page manual. You don't need that. This is for future reference if you want to learn Arena in more detail, okay? I encourage you to do that. If especially in your job somewhere simulation is needed, then at least save it. This is like, it has some advanced, it covers everything. But for now, where is that? Yeah, there is a document given to you called, I think, table of contents or something, a smaller version of it. And this is only 20 pages. 20 means, it should not take very long for you to read this one. Even it has some extra components. But I'm going to again leave it for you as a reference. I want you to have a look at it later. We are going to handle it directly into the Arena. So whatever I'm discussing, it is basically explained there. So I'm going to open a new window. So this is Arena interface, okay? Let me see if it's still recording. Now it has what you call different toolbars: basic process, advanced processes, and then advanced transfer processes, flow processes, packaging processes, statistics, reports, navigate, and many other things. For us, at this stage, at this level, we are not doing advanced, so basic, process, and reports are the only two which we are concerned with. Okay, everybody okay with that? So you need to know that once you open Arena, see which one is open. So we are only concerned with basic and then with reports. Now, how does it work? There are, like whether you, these are called objects. You have to make use of these objects. So there are some objects, and then there are something called data entries. So let me just start with the most basic one. The first four actually are the only one which you'll be needing in your projects. Only first four. You understand that? And in the class exercises as well, in the exam as well. So the first four are the only one, even within basic processes, these are the only ones. And perhaps we'll be using this record later in next class, record and assign as well. But this is the like the maximum we're going for Arena. So what do you have in a queuing system? You have queue. Other than queue, what do you have? You have arrivals, and then you have queue, and then you have the service, isn't it? So arrival, to simulate arrival, we have what you call create. Okay. Now for the process service, we have what you call process. And then, we have something called dispose, which you haven't seen before. We take it for granted. Dispose means we allow entity to leave the system. This is like a single service queue. Now, like the departure, I have this USB, and the name of the folder is like 15 point something, some version number. Okay. Do you see this one? Just look at this number 15.00 and something like that. Just copy this folder too. Okay. And whoever is facing the problem, you can copy just this folder for yourselves. Okay. Okay. And then in the meantime, you can install as well. Let me see if I can zoom in. Can you all see this well? So this is like we are creating MM1Q. So how do you make it work? Banat, you all with me? So you click on create. You can give it another name if you like. I can say customer, arrival, or whatever name you'd like to give. And this arrival is simulating the arrival of, let's say, big trolley customers. So I can give it a name, big trolley customers. Okay. So there are two components. One, the create itself. And then there's something called entity. You know what entity means, right? So I'm telling that create is, I'm giving it a name customer arrival, and I'm saying that this will generate randomly these entities called big trolley. Now, how would it work? I have to give a distribution here. First of all, units. What units are we typically using here? Minutes. So I just have to make sure that it goes into minutes. Otherwise, it will be a problem. Then it's not taking rate, so it is like exponential distribution. So what would it go here? Lambda or 1 over lambda? We'll see. Anyways, I'm going to put 1 here, random exponential. There are some even more things mentioned here. Entities per arrival. In many advanced systems, there can be scenarios where each arrival comes with not one entity but multiple entities together. Think of buses arriving in Hajj, right? So each bus is carrying one person or multiple people, right? So if randomly buses are coming, how would you simulate the arrival? Because each bus, 50 people will come out and stand in a queue. Then another bus arrives and 50 people will stand in a queue. You understand that? So this customer entities per arrival is taking care of that. How many maximum arrivals are possible? In MM1Q, we assume it to be infinite. But if there's a restriction saying that there are a maximum of 20 people, no more is possible. Possibility. It's not saying that infinite will come, but infinite simply means that you're not putting any restriction of how many people will come. Okay. And then first, what does it say? First creation. You want first creation right at the beginning, or you want to leave it? You can just leave it for now. Okay. I'll say okay. Now let me go into process. Now you can say counter 1. You're all following me, Banat? Stop me if you're confused anyway. Now, this is a very, very important part, this action. It again captures so many things. Can I? Zoom. Okay, let me try to use magnifier. Okay, can you see this well now? Let me see if I can make it 150. Not. Is there a 150 option here? Not speed. It's okay. 200 is fine. We'll manage. So, so what I did was I clicked on process. By the way, I don't have to click. Once I click here, there's something that comes. Let me just close it for now. Then I'll open again. So where is my? Okay, so when I click on anything, you see that something comes at the bottom as well. Okay, I'm going to use the magnifier again, but I can double click and the same thing will open in a box like this. So this thing and this thing down there are the same thing. Okay, so whichever you feel more comfortable using with. So anyways, I'm going to open the magnifier again. Okay, so now I'm talking about process. Okay, so when I click on process, you know, the first thing I must deal with is the action. Now in processes, again, Arena is designed for general purpose use. So it captures everything. So when you just say delay, it's like a hall where people wait. There is no resource assigned to it. You understand what delay means? Like someone comes and you just, you know, many people even can come wait in a single place and then there's no resource to capture. Then there is something called seize delay. And then there is something called seize delay release. Now the first two are what is extremely important to you. Seize delay release means in the same process, an entity comes in, it will seize the resource, get the service, and the resource will release. And then the entity will leave the process. Leave the process, so far not the system. Do you all understand seize delay release means? If this is the process, this is the counter desk, so I walk in, I'm seizing the resource, I'm getting the service. So this is delay represents the service. Seizing means, you know, the person is now attending to me. Giving me the service is delay. Release means I done and I leave. So the resource is no more taking care of me. But there's an option where you have seize delay. Where is the release and where does that happen? In hospitals, if you have noticed that there are situations where a nurse, you go to a nurse station, the nurse takes care of, you know, does all the measurement, and the nurse, rather than saying, I'm done with you, you can go to the doctor, it can happen, but there are situations where nurse say, come with me, I'm going to take you to the doctor. So we go to the next process while that resource is still seized. I have not released it. So during that process, I have not released it. I'm carrying my resource with me. You understand what I'm saying here? So that's called seize delay, delay release. It means that somewhere else, there's another process where I don't have to seize it because it's already seized. So I'll just do delay and then I'm going to release it at some later process. So what am I doing here in your cases? What are you following? I think in all your cases, you're following seize, delay, release. Okay. So I'm going to pick seize, delay, release. But by picking seize, delay, release, I'm going to be seizing what? A resource, right? A resource has not been created. So it says I cannot find a resource. So I'm going to say add, and I need to give it a name. I'm going to call it. Yeah, when I say seize, when I pick the option seize, it means I have to seize the resource. Okay. So where is my resource? There is no resource I have created so far. So it says where is the resource? I can't find a resource. So now I'm creating it right here. I'm calling it a cashier. Okay. And how many units to seize during one process? One counter, one cashier. Okay. So I'm creating one. And I'm going to say okay. So one cache number 1 has been created. Manoj, you all with me? These two things. It has to be cease, delay, release, and then I have to create a resource for it. Okay. Don't worry, we'll be creating, we'll be solving at least 3 or 4 examples on Arena, and then we'll be doing your projects as well. So this class will solve at least a couple of examples. Next class, we'll move on to your projects. We'll create a simulation model like this, okay? So now, service distribution. Do you remember that in the notepad file, you saved service distribution somewhere as well? You can, first of all, is this units in hours? Make sure you set it to minutes. If it is following triangular distribution, just put the numbers in. If it is not following triangular distribution, see what else it is following. Uniform. In my case, uniform, fine. I can give min max, but I think you said beta, right? Did you say beta? You said beta? So where can I put beta? No. But what we do is, if we want to enter anything other than triangular and uniform and normal or constant, we use something called expression. Expression, when we say expression, we can just paste the expression here. The one you saved in a notepad file. The whole expression. You got that? So 3 point, you said some number before beta and something, right? So the whole expression, 2.5 plus beta or whatever parameter. So all you have to do is to copy paste it here. Okay, so that expression goes here. Now I'm going to just keep this expression here. I'm going to say okay. There's nothing you have to do dispose, because there's nothing you have to configure. You don't have to configure anything in dispose. Okay. Now I'm going to close this magnifier for a second. So do you see that before there was no line on top? When we created the process, there was no line. Okay. Okay. So Banath, are you all with me? So there was no line before. This line represents queue. There was no queuing because delay means everyone can enter. You can actually move this queue a little if you like. Visually, you want it to look, if you want it to look better, you can move it like this. So visually, it's very easy to deal with, okay? All following me? Now all I have to do is I can run this model like this. I haven't saved it. So it is creating arrivals, queues, build-ups, and everything. Okay, I'm going to stop it here, but it will. Right now, there's a problem. The problem is, once I started simulation, I said that infinite number of customers are possible. So when will the simulation end? It will not end. So we have to do what is called setup. Simulation setup. So if you go to run, there's something called setup. So I'm going to zoom in again, use magnifier again. Okay, so I went to run, and then I clicked on. Oh, sorry, my bad. Okay, so I'm going to close it. So I went to run, and I clicked on setup. Okay, Banath, you're with me? Now there are a lot of things that I can do in setup. I say, first of all, recording units, time units, report me in minutes. Time units will be in minutes. Just set it up to minutes, everything. Okay. Now replication length is, I say run it for 8 hours only, or because it is in, I can keep this hours, 8 hours. I say 8 hours, okay? Or 8 into 60, I can give it in minutes as well. By the way, this is the base time unit. This is important. I say there's something called warm-up period. This is a more advanced concept. where because you start simulation, so you want to not record data in the beginning so that it becomes more natural. So your warm-up period is like the period which you ignore in your reports. So you let it run for a few minutes, and then you say start recording the data from here. The simulation mode. Okay, but it's fine. We'll keep it to 0. Now, do you see this hours per day? But not do you see these hours per day? This is a situation where I say I want to run it for 24 hours, but I'm working 8 hours a day. So there are advanced options. It means what? It means the simulation will run for 8 into what? 8 into 3, 24, right? So it will run for like 3 days. 8 hours, start again, run for 3 hours, 8 hours, and then for the third day run for 8 hours. So it goes like this. So again, we don't have to touch anything here. We'll just say run it for 8 hours. And then there are some advanced options. We'll not go in there. By the way, simulation is dealing with what kind of processes? Stochastic or deterministic? Stochastic or deterministic? You remember these two terms? And in stochastic? It's random. Don't forget this term. You're making me worried about the exam. And so we make sure you know all the terminologies and everything. Okay. So stochastic is just another name for randomness, random processes, right? Random process means if we run a simulation. So my question is, the arrivals are being done in what manner? Random manner, right? The service is done random manner. So if we run a simulation and we run the simulation again, what will happen? Is it going to be identical? It's not going to be identical. So what makes things reliable? When you read the results, what makes things reliable? You have to what you call replicate. You have to run it the same simulation several times. And then the average of all those replications will be more reliable. You understand that part? Yes or no? So I run the experiment first time, 8 hours. Khalas, my simulation is done. I'm going to do it the second time, I'm going to do it the third time, I'm going to do it a few more times. And then the average behavior across the replications will be the much better representation, because one replication, strange thing might have happened and it may not be true representation. Okay. Okay. So the number of replications, I'm going to keep it 1 for now, but this is where you set the number of replications. For your projects, I would suggest to do replications at least, let's say 5 times minimum. Okay. So if you do it 5 times and you run, you'll see Arena running 5 times. The same model, run, finish, run, finish, run, finish 5 times. And in the reports, it will give you a summary and individual reports. So, so let me just save it. Let me say, okay. So now everything is done. I'm going to close the magnifier. All I have to do is to run it. Now it will run for 8 hours. I can accelerate it. What happened now? What happened just now? It has thrown me an error. What is the error? Let me tell you what the error is. And this is where we are stuck with what you call academic version. What does it say? For your case, for the case that you are dealing with, you're fine. Normally, it handles what you're dealing with. For me, I created 2 fast arrivals. So it's generating fast and it's not providing the service with the same rate. So the entities exceeded it exceeded 150 and I say I'm not going to solve anymore. Okay, so that was the problem. For this case, I'm going to stop it here. I'm going to go back. I'm going where is? Okay, I'm going to close it. I'm going to either accelerate the process. I'm going to say, okay, triangular, but 0.5, 0.2, and 1. Let's see if it is okay with me, just for the demonstration purpose. Okay, now okay, so it has finished simulation, okay? But I want to run it again by controlling the speed. You remember visual validation? We talked about visual validation. Okay, so I have to stop it and then run again. This is like running really slow. I wanted to see if it is running visually, it is doing what is expected to be done. I can accelerate it further. Right? Anyways, I can make it run very, very fast. Now I want to see the results. So next thing you need is to go to which tab? The reports. It is generating the reports now. Okay. So the total number it handles is 481. I want to look at reports related to entities, report related to queues. So there was one queue. What is the average waiting time? 0.43 minutes, because our report is in minutes, right? So what about resources? Resource was busy 57% of the time, instant utility. Percentage of time it was busy. Number of customers it has ceased to provide service. Can you all see this thing? So a lot of insightful reports are there, depending upon what problem you have modeled. Now imagine if this queue average waiting time is turning out to be 20 minutes. This is where it is telling you that there's a problem, right? Now I'm going to show you. I'm going to go back to basic processes. Sorry, let me close this report. Now I'm going to run setup. I'm going to show you the effect of replications, 3 replications. Okay, and then I'm going to run again. Oh, sorry, I have to stop it and then run again. So you can see that it will run. It has actually, you'll eventually, I think somewhere you'll see, it will be reporting replication 1. Can you see replication 1? Why is it not showing 3 replications? Yeah, 3 replication. Oh yeah, here. This is replication 2. This is replication 3, right? So you can see that there are small differences between them. So you can take the average. I think it summarizes the whole thing. Let me see if it queues. This is like the summary. You can see the summary here, right? Queue. This is across the 3 replications, right? So average is 0.39 minutes across the 3 replications. Can you see this thing? So these reports are very powerful. You can see Arena is very easy to handle, isn't it? The difficult part is just some of those blocks. Do we have enough time for today? I don't think we have enough time for today. You have the USB. Please make sure you install Arena, see the recording, and do this part what we did today. Yeah? You can bring it back Wednesday. No problem. Okay? You see, it's not difficult. I'm going to show you a few things which we may need to learn. What I have given you are actually 4 examples. If you want, you can even look at it by yourself. This is exactly the example we did, right? So it is an example given to you. There's another one which has multiple processes, one after the other. Okay. And by the way, you can just drop a graph and plot the, we can look at this later. But what is important is this exercise. This one is the most elaborate exercise. You learn all the things you needed to know, even more than what you need to know about your projects. So next class, we are just going to be doing this one. The first two examples are you should be able to do by yourselves after today's class. Okay. So click each one of them, not this one, the ones before, and then inshallah you'll be fine. So I just wanted to show you something more simpler. Let me see examples. Yeah, the one I showed you a long time ago, sorry, not this one. The thing that will be tricky for you is this part, the decision part. So this is another one, as I told you, create, dispose, process, you already know. Inshallah, next class we'll talk about that. But inside there is, you need to somehow, you can see, I think you're not been able to see this well. So let me use a magnifier. The only thing that gets tricky is to define a logic for making a decision. This is where you can see that it's like a small program. You'll see that even this one is not very difficult. It says that number of Q in process 1, Q. If it is less than number of Q in process 2, Q, then go this way or go that way. You don't have to write it yourself. The arena still allows you to visually pick. You click, and it generates this expression for you. But this is the only tricky part. The rest is very easy. You can see, you saw already, that it's not very difficult. So what is my expectation from you today? Install Arena. Make sure you know how to run Arena Input Analyzer. Make sure you know very well the Excel part we did. Remember the first thing we did was Excel processing? You know when I am doing lambda and mu, and when am I doing 1 over lambda and 1 over mu? And when I have lambda, how can I find 1 over lambda? And when I have 1 over lambda or 1 over mu, how can I find the mu? Okay? Make sure you are expert in that. Then try to build ML1Q like we did now. This is 3 exercise 03-01, something given to already provided to you, in a zipped file. Then there's a second example which not only have one process, but multiple processes. And there's a PDF file which is explaining the problem, saying that you went into an insurance company or something like this, you went to the first desk, then you went to the second desk, you went to the third desk, right? So you just follow that thing, and the model is already built in front of you. So you click each one, each box. You see, open the arrival, see if it is configured the way it is written in the problem. Click this second box, see if it is configured in the right way or not. Right? Run, see the reports. Try to understand what reports are telling you. The third example is more complex. I don't think you'll be able to pick up the things. Inshallah, next 2 classes we'd like to finish everything. The first part will do this example, and then we'll jump to your projects. So all you have to do is to create a model like this for your projects. If we cannot finish by next class, the class after, inshallah, it will finish that. And then you have to finish off, print those reports, it gets printed in PDF form or something, you can save it, put it in your files, and Word files, just create your reports and submit. Okay. Is that good? And if there's no question, we can stop for today. Okay, so if you have any problem installing Arena, please don't wait till Wednesday. Okay, make sure if you have any problem, just send me screenshots or something. And by the way, I need to show you something, just to make sure that I'm going to go to this folder. So once you go there, you go inside there. You have to go to media image and then click on Arena. Okay, you understand that? You have to have the whole folder copied on your hard disk, or you can install it directly from the USB. Click on media image, and then click on Arena, or you can click on Auto Run, whatever. If it doesn't work, you can go to Install Arena and Setup. By the way, it should not be needed. Just click on Arena and it should start. Oh no, not this one. Sorry, it's just an image. Auto Run. Yeah, I'm not going to run it because I don't want to mess up with my own. Okay. If you still have a problem, please let me know. Okay. Okay, we are going to stop now, and inshallah, see you next class. Yes.